All right, welcome to Converting from Degrees to Radians and Back. Now on this video, be shocking, on my worksheet I made a kind of large mistake, so we're going to find that in a minute, but it's for fun. It's like a little scavenger hunt for you. Okay, first, you probably heard that we have these different ways to measure angles called radians. And where they come from is interesting, so I'm just going to show you briefly where they come from. If you take a second, pause the video, so you can do these two questions on your own. Okay, so hopefully you tried it. Find the circumference of the circle. Remember, the formula for the circumference is 2 pi r, or if you want to stick with the just pi times the diameter. So the radius is 1. So the diameter is 2, so the circumference is 2 pi. I had a really bad stencil here, so whatever. If the degree of the angle, which is the central angle, is 50 degrees, what is the degree of the arc? So with that one, you have to use your knowledge from geometry. I know, it's awesome, right? So remember, if this is a central angle, and this is the arc, remember, the central angle and the arc are the same. If this is 50 here, oops, excuse me, if this is 50 degrees, so is this arc that it cuts. So using both that knowledge here and this knowledge here, if this is 50 degrees, that's how we create this whole new way to measure angles. So we know that this whole angle is 2 pi all the way around. I mean, like the whole arc, all the way around, the full circle is 2 pi. So all the little angles that we make, or the big angle that we could create with this, is also 360 degrees. And then we can cut it up for smaller angles. So I know that's kind of a deep concept, as I mentioned right here. This is a deep concept. Just realize that there is another way to measure angles. So with 360 degrees, we just said that. How many is that in radians? Well, that's 2 pi. That's the full circumference, or the full circle all the way around. So if we cut it up, say we only want half, or we only want 180 degrees. So if you remember, with a circle, we sketch an angle, if we were to sketch 180 degrees, it would go halfway. So half of 2 pi, well, that would be just plain old pi. Okay, 90 degrees. That's half of that, so that's pi over 2. Okay, because this is, hold on, I got this. This whole thing is just pi, so if I only go halfway, it's half of a pi, or pi over 2. Right? So 270 tends to throw people sometimes, but let's just think about it logically. I like to count by halves sometimes. So if I think about this as, from here to here is pi over 2, and this one is 2 pi over 2, 2 pi over 2, which is just plain old pi, and then all the way around this would be 3 pi over 2, and this one would be 4 pi over 2, 4 pi over 2, which is 2 pi. So 2 pi is 360, 3 pi over 2 is 270, and 0, well, is just 0. So, knowing these, it's a nice thing to know these particular angles, because then you won't have to convert them. But if you say didn't understand the 2 pi, the 3 pi over 2 thing, that's fine. We have a way to convert, and this is where Barris created her first mistake. Because I'm crazy. That is wrong. It should be the other way around. It's pi over 180. So whenever we want to convert any angle at all, we simply take the degrees and multiply it by pi over 180. That's it. Done. And then we have our radians. Okay, it's a nice little formula, and that's all you do. So the first thing is, there's two ways that we ask this question. We either ask for it in terms of pi, which simply means you don't put pi in your calculator when you're doing the math, and you just leave it. So for example, it's 30 over 1 times pi over 180. Okay, we just do this math. Now, those of you that like your calculator a lot, you can do, I will do that in a second. But if you noticed here, this is simply a multiplication problem. So this is in the top, this is in the bottom. We can simply reduce them. 30 goes into 30 once, 30 goes into 186 times. So the answer is pi over 6. If you don't understand that way, let's try it straight calculator way. So I just like to make both of them fractions so we don't get confused. 45 degrees times pi over 180. And all you do, multiply across. So I get 45 pi. Excuse me, let me erase that. Which I can't. Awesome. So 45 pi over 180. Okay, now that's not reduced. So what you can do is ignore this pi here. Ignore the pi and simply type the 45 divided by 180 in your calculator. And remember, the conversion to a fraction is math, and then enter, enter. That's what you hit in your calculator. So then it reduces it for you, and you're left with 1 over 4, but you have to keep that pi in there, or else it's not radians, it's just 1/4. So you simply leave the pi in the top because you didn't reduce that pi. It stays. See that? So try 120 and 160 and then turn it back on for the answers. Okay, so here they are. This one is 2 pi over 3, and this is 8 pi over 9. All right, next. All right, sometimes we also ask you to find it to the nearest hundredth. So that means you put pi in the calculator. It's weird, but this is the harder. This is the easier one. To me, it's weird, but we simply do the same thing. If we have degrees, we convert to radians by multiplying it times pi over 180, and just do it. Just multiply 135. You don't put the degrees in. Times pi over 180, and the pi is the second button. If you can't find the pi, and then that to the button that's there. So second and to the, it's right above where E is on the division sign. Okay, so that's where the pi is. So 135 times pi over 180. If we want to round to the nearest hundredth, remember there's 2 zeros in 100. So we go to 2 decimal places. So that's 2.36. Okay, pause it for a second, and then I'll give you the answers. All right, so here are the answers. I had a little fight with my stencil, or my whatever this thing is. So 3.93, 4.19, and 5.76. Interestingly enough, all of these were rounded up. Okay, so second of many mistakes. We just converted degrees to radians using this formula, so that's not it. This one is 180 over pi. So if we want to convert from radians to degrees, which is actually more useful to us because we really understand degrees, at least I think we do, more than we do radians. So this will be useful when we're sketching angles and doing all of our work. So pi over 3, if I multiply that times, 180 over pi, you just reduce. Hold on. Okay, so we multiply it times 180, that's an 8. I suck at this. Okay, 180 over pi. And then you simply do the math. My dog is eating right next to me, so I apologize. Okay, so the pi's cancel out. If you can see, 180 divided by 3 is 60 degrees. All right, I moved his bowl. Let's see how this goes. Okay, so 10 pi over 9 times 180 over pi. And we simply, you reduce it, or just really you could just type this in your calculator exactly the way it is, and it will give you a nice clean, nice answer. But you do realize that the pi's cancel out. 9 goes into 9 once, and 180 20 times, and it does wind up being 200. Pi over 9 times 180 over pi equals 20. Okay, so you just simply plug that in your calculator. It's as simple as that. I do want to do one if they say if the pi isn't in the actual problem, which happens quite often. They want you to convert 3.2 radians to degrees. The process is exactly the same. You simply multiply it times 180 over pi, and you do the math. And really it's easier because the pi's aren't there, just 3.2 times 180 over pi. So that would be like 183.35 degrees. And you can put little degrees if you want, but since you're converting, everyone knows it, it's all good. Alrighty. Alrighty. So the next we're going to do is we're going to sketch some angles. But really anything that you want to do, you can, like if you have to sketch an angle, find coterminal, all the other stuff that we've been working on with angles. If you're given radians, simply convert it to degrees and then sketch it. So I'll do the first one and then you try the other three. So I simply want to multiply this times, since it's radians, I want to convert it to degrees. It's 180 over pi. Again, do the math. You should get negative 30 degrees. So you need to sketch negative 30 degrees. Now remember, when we did this, this is the starting position. It's negative 30, so we're going down. And when we go down, it's about there, about negative 30. Now when I label this, I don't label it negative 30. I do have to label it with the original, so it's negative pi over 6. Okay, try the other three. Well, actually, the other two that you sketched. This one is finding something coterminal. So try those and come back with the answers. All right, we're back, and here are the answers. I converted this one here to 135 degrees. So remember, it's positive, so I start here and go up. Sketch the angle. 135 lies in the second quadrant, and we label it with 3 pi over 4. This one over here wound up being negative 150 was the actual angle. In order to see where it lies, I like to make it between 0 and 360, or negative 360. So I added 360 to it to find out where it would lie. And remember, negative 150 starts here and goes down. So this would be negative 150. But since it's 510, I have to do the whole swirly around thing and come back. Find an angle coterminal. We just did something like that right here. But just to be clear, if this one converted is 10 pi over 4 converted is 450. I get it closer to 360, so I subtract 360. Get closer to 0, I guess I should say. And it's 90 degrees. Now we talked about what 90 was, but since they asked the question in radians, the answer should be in radians. So 90 degrees converted is pi over 2. You could convert it or just know that it's pi over 2. Either way. All right, I hope that helps. Sorry about the mistakes. Bye.